let's look at half angle. So we got double angles. Now we can look at what about those angles that are being halved. Right. Half angle identity. How to handle the half angle identity. Okay. And so I'm going to show you guys a little bit of some deriving work there. A little bit of deriving work. Okay. So we're all math people, so we got to learn to derive a lot of time here. Now, it's closely related to the double angle formula that we've learned earlier, the double angle identity right here. So I mentioned before that the cosine of 2x, right, or 2 theta, whatever, however you want to call it. X is the angle, but from a double angle over here, cosine of a double angle, right? We knew that was cosine squared of x minus sine squared of x. That was one of them. You guys recall? Okay. And then we had that revised version, right from your note right here. That's cosine of 2x will equals 1 minus 2 sine squared of x. Then we also came up with cosine of 2x equals 2 cosine squared of x minus 1. So we're not beating around the bush with these known information, but we want to take this and go a little further. So I'm going to specifically pay attention to this particular one right now, the cosine of 2x and all of that. So think of it like this. Cosine of 2x equals 1 minus 2 sine squared of x, right? Do you see the relationship between the 2x and the x right here? Have a close look. What's the relationship between the 2x and the x? The 2x here is double, right? It's twice the x here. Do you guys agree? That's one way of seeing it. But what about on the other way around? How about x here is half of that 2x, right? Isn't the x here half of that 2x right there? So here's, you can just put in an angle. I'm going to say just let theta be sub 2x. Then the formula here becomes like this. Cosine of theta will equals 1 minus 2 sine squared of, see, if theta equals 2x, then yes, x itself right here, the single x is theta over 2, half of theta over 2. Do you see half angle now? Right. So in that way, here's how I'm working it out right here. So from this relationship that now points out between some angle and a half of its angle over here, I can go, I'm going to add 2x squared to the other, 2 sine squared to the other side, and bring the cosine to this right hand side. So 2 right, sine squared of the half angle, right, equals 1 minus cosine of theta. And then I'm going to divide both sides by that 2, making it sine squared theta over 2 equals 1 minus cosine of theta over 2. Then I'm going to take the square root on both sides. That will now give me sine of theta over 2 can come out being 2 different answers. Could be sometimes positive, sometimes negative. Plus and minus square root of what I have here, 1 minus cosine of theta over 2. But ladies and gentlemen, what we have arrived here is a formula, an identity for a half angle. That's how we're calculating a half angle from a given angle. Now that's formulated. Let's put that into a list right here. So as far as the half angle, identities, right? The first one we wrote down. The first one we had sine of a half angle, theta over 2, equals to plus minus the square root of 1 minus cosine theta over 2. That's your half angle plus half angle identity, right? Put that in a box. I'm going to come back to this board right here, and we're going to derive the other half angle, sine of a half angle. Now, once again, from these two known double angle identities, I'm going to now focus on this other one, the one that relates between the cosine and the cosine of the 2 theta. Okay. And so what I'm seeing here, now by paying closer attention to this one right here, let's write it down. So what I have here now, cosine of 2x, right, equals 2 cosine squared of x minus 1. Is everybody with me still? And then just like that, I'm going to rearrange that. I'm going to keep the cosine square on one side here. So I'm going to add that one to the other side. So now I'm looking at 1 plus cosine of 2x equals 2 cosine squared of x. And then I'm going to divide both sides by 2, making it, and then I like to write this term on the left-hand side, so cosine squared of x will equal 1 plus cosine of 2x all over 2. And then, so in that similar argument, think about it. I'm going to purposely let some theta to equal 2x. If theta equals 2x, so theta itself, if the whole 2x here has one angle, then there's a relationship that means x itself is just only half of theta. Okay. And so now I'm going to bring that relationship into my work here. So anywhere I see x, now I'm talking about cosine square of half theta, right? And that equals to 1 plus cosine of simply theta. It's 2x substituted by some angle theta. Then divided by 2. So the same formula, the same identity. Now I'm seeing that as a relationship between some angle and its half, right? So now I'm going to take one more step forward here. I'm taking the square roots both sides. That gives me cosine of half angle theta over 2. That will come out plus or minus square root 1 plus cosine theta over 2. And we call this thing right here another half angle identity for cosine. Now we're ready to write it down, concluding it. Some angle theta over 2 that equals plus or minus square root of identity. You were the fundamental one. Keep in mind. Now, right from there, we can get straight into an example where we can see how directly we can use this into a lot of calculations. 3 pi over 8. Go ahead, have your unit circle ready. Where can we find a 3 pi over 8 angle on a unit circle? Do you see that anywhere? It's not there, right? So now think of this. The plan now is that 3 pi over 8 is the 3 pi over 4. Do you see this one on a unit circle? Over 2. 3 pi over 8 is half the 3 pi over 4. Are we good there? Okay. So there's that relationship. So now, upon recognizing that the angle we're looking at right now as our target is being some half angle of another known angle on a unit circle, right? Okay. The formula here you use. The sine of the half angle, right, equals, so right now as a start, just set it out right here, plus and minus, we've got possibly two answers. Right? And then 1 minus, now cosine of the angle before getting half, right? So cosine of 3 pi over 4, see what I mean? Right. And then divided by 2, square root. But so that's the problem with the formula, we got two answers, right? We can't go with two answers. So now we need to look into the quadrant information again. 3 pi over 8. Which quadrant will 3 pi over 8 hit? Even though it's not on your unit circle, it's nowhere shown on your unit circle, but where can we find 3 pi over 8? Think about you draw the unit circle, right? 3 pi over 8 is half of 3 pi over 4, so 3 pi over 4. 1 pi over 4, 2 pi over 4, 3 pi over 4 is about here, right? You guys follow it? So halfway of that land to right about here. Am I making sense? So 3 pi over 4, so in what quadrant is this now? 3 pi over 4 about there. What quadrant is it? The first quadrant, right? 3 pi over 8, right? In the first quadrant. See what I mean? So for first quadrant, can we have a negative sign value? We cannot, right? First quadrant, we cannot have a negative sign value. So for that reason, now, after knowing that, right, we can go with just now simply the positive, right? 1 minus cosine of a 3 pi over 4, dividing that by 2. And the calculation now is ready for us. So now I'm just writing down the ugly setup, and then we're gonna take the time of using it after. So square root, right? Big square root and 1 minus square root 2 over 2 and all over 2 right there. See what I mean? Right. That will come out being 1 cubed square root here. The 1 minus square root 2 over 2 is a 2 minus square root 2 and all over 4 inside the square root. Right. So now you can turn that into something like this. The square root of 2 minus square root 2 all over 2 outside the square root. You may want to arrive at this final answer like that. And I want to bring in another problem here, partly. So it's just straightforward computational problem here. Cosine of a 22.5 degrees. All right. So for this straightforward computational problem, once again, what to recognize? The 22.5 degrees angle is not found among the common angle in your unit circle, right? But then here's the whole reason why we have this problem here, this example problem, right? This particular topic where we're talking about half angle identities, seems because now think about the 22.5 right here. You now realize it is half of a 45 degree angle here. So another way of saying that 22.5 can be re-expressed as half of the 45 degrees. So that's our realization about this angle in particular, right? And so now we're going to go ahead and rewrite it. So that means it's the same as the problem here we do it. It's the same as calculating cosine for the half angle, half of 45. And so now upon realizing that what we're doing here is a half angle, here we have the half angle formula, right? So here we're looking for cosine of theta over 2. So theta in our case is a 45, and we're looking for half theta. So the angle I'm about to use, well, the formula I'm about to use here, by default, it comes with 2 answers, right? Plus or minus. So let's go ahead and write it down in the way how it is. And then we got 1 plus. Now we need to only take cosine of 45, the main angle, which is easily defined for us, right? And then that's divided by 2. Everything is doing inside of the square root. And then before I proceed into any further calculation, now think about it. So we need to decide, because we cannot have 2 answers, right? So we need to decide which one is the suitable, the proper answer for our case here. So now that means we have to look at our own angle over here and decide the quadrant information, right? 22.5, which quadrant is it in? It's in quadrant 1, right? So quadrant 1, that means the cosine has to be positive, right? The 22.5, right, according to what you guys are suggesting, and we all agree with that, right? It's in quadrant 1, right? So that means that leads to the understanding that cosine of 22.5 of the angle has to be a positive number. Okay, so now in our next step, we're gonna choose the positive square root. Okay. So the positive answer now is gonna go 1 plus cosine of 45 degrees, and we divide that by 2. So these are all values that we can easily obtain through the unit circle among the common angles. Now in that case right here, it's 1 plus, right? 2 over 2, so 1 plus square root 2 over 2, right? And then we can go ahead and make common denominator for the 2 terms here in my numerator. So that turns that into 2 plus square root 2 over 2, and over 2 again. So I learned, I experienced a little bit from my earlier problem of the same example that I wrote my work here a little too rough. So some of you may not recognize it. See, adding these terms, you got to make common denominator and all that, right? And then now we got a fraction divided by another fraction right there. That's what makes it. That's what makes it now 2 plus square root of 2 and over 4, right? And then the property of square root here allows us, see, we got a square root of a fraction right here, so now we can break that square root into 2 separate square roots. One square root is for the entire 2 terms, 2 plus square root, 2 on top. Okay, so we got square root of 2 plus square root 2 on top, and then we divide it by 2 at the denominator. That's our answer right there. Okay, that's our final answer. And so another problem right here for you to see the usefulness of that. So still in example 1 part C here, what about, let's calculate tangent of 22.5. So this part C right here is purposely connected to part B that we've done earlier, the same angle with that, right? Now we're looking for tangent. So once again, what we realize here is that, and by the way, tangent is the sine of 22.5, right, over cosine of 22.5. So according to what I said earlier, that this problem we're doing is directly or purposely connected to the earlier problem, because we already had cosine of 22.5 found, right, in part B. So that's easy. So really what's waiting for us here is to calculate, the big part here is to calculate sine of 22.5 here. We had similar work in part A of the example earlier. So 22.5 is recognized as 45 degrees over 2. So half 45 degrees. And so that gives me, and that means the angle we are, right, 22.5, it's easy to tell that it's in quadrant 1. That's just something that we can easily observe. And then that leads to, later on, we're going to have to use the sine value of 22.5 has to be a positive value. Okay? So these are some preliminary information. Right? So now we're going to just go ahead and calculate sine of 22.5. So sine of 22.5 is the same as sine of 45 over 2, right? And so according to the half angle formula that we have learned. So I'm not going to beat around the bush writing the 2 separate formulas anymore, because now we already knew that sine has to be positive, right? This answer here has to be a positive, so now I'm just going to go straight into the positive square root. Because remember the formula says plus and minus, right? But now we already knew, sort of like we did some, planning before getting into the problem. We knew that the answer got to be a positive answer. So I'm just going to get straight into that positive formula. Okay? So now the formula here says we got 1 minus, right, cosine of 45 degrees, and we're dividing that by 2. Right? And so in my next step here, it gets me, right, positive square root, 1 minus square root 2 over 2, that's cosine of 45, right? And then we're dividing by 2, and then we're going to do some further simplification work. So I'll have, now it's square root, we got 2 minus square root 2 over 2 and over 2. So that all reduces down to a square root of 2 minus square root 2 over 4. And we can reduce that down to a square root of 2 minus square root 2 over 2. That's sine of 22.5 degrees again. But that's not our goal of the problem. We want to calculate tangent of 22.5 right from the beginning. See what I mean? Right? So in that way, right here, in that way we must go tangent of 22.5 degrees, right? It's a long process, but it's just because I'm showing you every single little step like that. But when you're actually doing this, it's going to come a lot faster. So sine value we found previously, square root of 2 minus square root of 2 over 2, divide that by another square root of 2 minus square root of 2, and 2. Right? So that's how it looks for now. Should have been a plus here. sine and the cosine value to be divided by each other. And so algebraically, we're gonna rewrite it as 2 minus square root of 2 over 2 times 2 over square root of 2 minus square root of 2. And the 2 here got canceled. We're looking at 1 square root of 2. Typo there. 2 minus square root of 2 at top over the square root 2 plus root 2 in the denominator. And we can even further rewrite all this. We can even further rewrite all this into 1 square root. Yeah, so 2 minus square root of 2 over 2 plus square root of 2. All right, and so we can stop right here. And if you're good with the rationalizing the denominator, you can even proceed further with that. But it's just a matter of how you're willing to do the simplification. That's all. All right. So there's another kind of problem that I want to introduce as an example. Right? Tangent of u over 2. So u is the angle. Okay. So right from here, here's how I see it. It's tangent again, very similar to the example we've done earlier, right? And then we've done that ton of time this time. Tangent is easiest access, easiest to remember, right? Is to do sine over cosine. So tangent of the angle u over 2. I'm not saying that it's the shortest route, but it's the safest route with that. We get sine of u over 2, and we divide that by cosine of u over 2. This is sort of like in the most limited situation, but we always have safe access to that, right? Having a direct formula for tangent of a half angle is not important. So now we need to know these two values, cosine of the half angle of u over 2 and sine of the half angle of u over 2. Now, cosine is given right here. Cosine is of the angle. Now this is the ordinary angle. In the formula, we're looking for half of the angle. Right? So cosine of the ordinary angle, here this is how I'm seeing it. Now, sine of the half angle, sine of u over 2, according to the formula that we have here, the half angle identity, it needs to be, once again, plus and minus, right? Square root of 1 minus cosine of u over 2. So that's just the writing down of the half angle formula. But now again, we gotta make a choice. So that's one major problem with dealing with the half angle formula. We always have to watch out for the angle quadrant so that we know which one to pick. We gotta know which one to pick as the correct final outcome for our half angle sine value or half angle cosine value. See what I'm saying? No? So, but things go a little abstract here. So we need some scratch work. Okay, so there's our formula, but now we're about to decide this, right? So think about it. Now, a lot of times earlier we got an actual value for the angle, so it's easy to tell which quadrant it's in, right? But now things going a little abstract. All we know is the cosine value, but we indeed never knew the actual angle. So all I know is it's in quadrant 1. So u being in quadrant 1, another way of seeing it, quadrant 1 means u, the measurement of u has to be anywhere greater than or equal to 0 and less than or equal to pi over 2. Right? You guys following me on that, chicken? It's a very important skill that you guys realize. In quadrant 1 means it's anywhere from 0 to the pi over 2 angle. See, as a positive rotation, 0 is here, pi over 2 is here, anywhere between. Sounds good? Okay. But now we want half of the angle. So with a little bit of math background, we have to do this. U over 2, that's what we need. So we're going to divide all three sides of this inequality by 2. So that makes it what? U over 2 has to be greater than or equal to 0 still, right? Let's divide that by 2, right? It's still going to end up with 0. Divide this by 2 as well. See what I mean? So that means what? U over 2 as our main objective here is still anywhere from 0. And 0 divided by 2 is 0, but pi over 4. You guys good? So anywhere from 0 to pi over 4 will for sure still keep our half angle in the first quadrant. You guys following me on that? Okay? Right. So now that leads to that leads to the conclusion that yes, u over 2 would be for sure in 1. That's, I'm talking about solid exception that we presented. We don't just make blind arguments, right? We don't just make statements and then leave the proof out for people. We're proving people that, hey, our angle, the original angle is in Q1, that means half angle, this is how it is solidly in Q1 as well. Right? And so now that means we choose, that means back to that point, the sign of u over 2 will have to be the positive expression. Sound good? 1 minus cosine of u, right? Positive expression over 2. And now it's just a matter of throwing the values in. So I'm gonna swing over to this order. All right. So now that means we got sine of u over 2 will be, right? Here, in this case here we're talking about square root of 1 minus. See what was given about cosine of u? Cosine of u was given to be 0.384. Right? So that was given information. So there's no need to shop around. So 1 minus 0.384. Right, over 2, we keep that inside the square root. Good, that's so far. Okay. And then so, for now, because eventually we only use this as a way to get to the tangent, right? So I'm gonna hold on to the simplification here. I'll just leave sine of u over 2 here. Now, we also need cosine of u over 2, of the half angle. You guys follow it? Okay. The formula, again, comes with 2 versions. That angle could be, that cosine value could be positive or it could be negative, right? Plus or minus, but we got 1 plus cosine of u over 2. We're good then. And then we're going to have to make a decision wisely, right? That matches with our description of the problem. And then I'm going to show you what we've done earlier would be a one-time investment here. You see the steps you're doing here, you don't have to reinvent it. Because once you've done it, you have made some good address right here. We have already addressed that the u over 2 angle, right, has to be in quadrant 1. You know what I'm saying? Yep. So being in quadrant 1, means now out of the 2 possible formulas here, we only choose, right? We only choose the positive one. Because quadrant 1 for angle in quadrant 1, right? Cosine value is going to be positive, right? So 1 plus cosine of u, right, all over 2. Right. So now we're going to go ahead and substitute in the value. So we got 1 plus 0.384 over 2. 1 plus 0.384. So this 0.384 right here was given, right, from your beginning problem like that. All right, so now you got sine of the half angle, you got cosine of the half angle, right? And now we're ready to calculate tangent. So tangent of half angle, and I wrote it down earlier on the other board. Let's just repeat it. So we need the sine of the u over 2 divided by cosine of the u over 2. Okay. Now we found the sine of u over 2 was that big square root of 1 minus 0.384 over 2, and then we're dividing by another square root expression, 1 plus 0.384 over 2 in the denominator. Good still? And so we can put that in one fraction, in one square root here. So we got 1 minus 0.384 over 2 and over, right? 1 plus 0.384, right, over 2. Take that inside the square root, and now the square root can be reexpressed as the square root. Here we got 1 minus 0.384 over 2, right? We multiply that with 2 over, right, 1 plus 0.384. Right? So now we cancel out the 2 here. And that now will leave behind for us. In the square root expression, we got 1 minus 0.384 divided by 1 plus 0.384. So now you guys just go ahead and do the final calculation on that, right? And then take the final square root. That's all it needs. Okay. The final answer is just a matter of punching it in the calculator. So that's how we're handling this kind of problem. Okay. All right. So before we close down, so as far as getting the problem here done, it's done, right? But before we close down the example, so what's the generality about this example that I want to mention for everyone? See, Yes, we're calculating. What we're calculating is a trig value, right, of a half angle. But what you know here is we have a given, right? Right here in this problem, it's just cosine, but it could be sine, it could be tangent as well. Okay? What we have is a given trig value, right, of the angle theta. And then you're calculating, right? You're calculating a trig value of the angle of the half angle. Good. You're starting out with some given trig value of the big angle, of the original angle, and then you're calculating a trig value of the half angle. And then further you have the quadrant information must be given. Quadrant information. And that's the idea of that. And so if we use the quadrant information and pay attention to this step I'm doing right here is that a lot of times you only have the quadrant information of the beginning angle before we cut it in half. See what I'm doing there? But then we can easily use that, right, to make conclusion about, hey, if u is inside of that interval, then u over 2 has to be half of that, has to be in whatever else quadrant consequently. See what I mean? So that's how it happens again.